Hi, in this video, I want to introduce frequency filtering to you. But before we get on to frequency filtering, we need to have certain basics in place. And the first thing that I want to talk about is the frequency representation of signals. Okay, so let me just write that down here and then we can discuss it. So, frequency representation. Sometimes it's also called the frequency domain representation of signals. Okay. Now, one of the ways to think through it would be to think of a very, very simple signal. So let's take a sine wave, for example. So let's say you have a sine wave like this. Y of t is equal to a sine omega t plus theta. Okay. This signal can be represented in two different ways. Okay, one way is the most straightforward way. So if I want to represent it, what I do is I put time on the x-axis and I put y on the y-axis, and then I plot the signal. And what I get is something like this, isn't it? Uh, and you can continue this signal all the way across. And the amplitude here is a, and I'm assuming here that theta is 0, and let's just leave it like that. Okay, and you can fix out the other parameters in the graph as well. Now another way of talking about the same sine wave would be to say, well, I really don't need the values of the signal at every instant of time, right? I don't need that you to tell me that this signal has this much value at this time and this much value at this time and this much value at this time. That's what this graph is doing, right? I don't need that. Why don't I need that? I don't need that because this sine wave is fully defined if you tell me the amplitude, the frequency, and the phase. If you give me these three quantities, you have told me everything I need to know about this particular signal. Okay, so in one sense what I can then do is I could plot a graph like this, right? I could say, well, instead of time on the x-axis I'm going to plot omega, or I could do f as well, which is omega over 2 pi, right, with the frequency, and I plot a on this axis, and then I say this particular sine wave is just represented like this. So this is the frequency of the sine wave, and at that frequency you have this particular amplitude. And if you want to plot phase as well, I can plot another graph where again omega is on the x-axis. Okay, and then this is theta, and I say at this particular frequency the theta is this much, and that gives you all the information that you need about this sine wave. Now, why would you do that, you ask? Well, here's the thing. Now let's say the signal is a little bit more complex, and let's say it's a sum of two or three sine waves. Okay, and for a moment what we'll do is we'll just ignore the phase and just think about how the signal would look. So let's say your yt is equal to a1 sine omega 1t. I'm just assuming that the phase is 0 in all the cases, but I don't think the discussion changes much even if you have phase, other than you'll have to have another graph for the phase as well. Plus a2 sine omega 2t plus a3 sine omega 3t. Let's say we have a signal like this, okay? And again, what you could do is you could give me this signal in the time domain. You could tell me the values of the signal at each instant of time, and I'm not really sure how the signal would look because it depends on a1, a2, and a3, but let's say it looks something like, well, it will be periodic, but my drawing is very bad. So okay, so the signal could look something like that. Now instead what I can do is I could also plot it with frequency on the x-axis, can't I? So if I have f here, or omega, whatever you want to use, and I have this as omega 1, this value as omega 2, and this value as omega 3, and all I then need to do is I'll tell you, well, it needs to have this amplitude at omega 1, this amplitude at omega 2, and this amplitude at omega 3. And the amplitudes, of course, are A1, A2, and A3, right? And once we have these, you have all the information that you need about the signal. And in this case, it looks like the frequency domain representation is much easier than the time domain representation, right? Now, why are we talking about this when we should be talking about frequency filtering? Let's look at that in the next video.